Hi folks, here are a few more Chapter 3 homework problems. Here's number 14. For a movie stunt, a motorcycle must jump off of a horizontal cliff 40 meters high and land on a flat river barge that is located 90 meters away. At what speed in miles per hour must the motorcycle leave the cliff in order to land safely on the barge? So this is another horizontal projectile problem. So our little motorcycle is up here, and put a little driver on there. This little motorcycle stunt person is going to go wee like that. We know the cliff is 40 meters high. We know the barge is located 90 meters away. Our question is, at what speed must the motorcycle leave the cliff? Well, we want to know this velocity, which is the horizontal velocity. That's my unknown. So as in all projectile problems, you have to have two columns of numbers, the horizontal and the vertical. Horizontal stuff, we know the displacement is 90 meters. We're looking for horizontal velocity because that's what we're after. We do not know the time in the air. Vertically, we know it's going to drop 40 meters. That's my vertical displacement. We know gravity is going to accelerate it at 9.8 meters per second squared, and the original vertical velocity is going to be 0. Again, we do not know time, but once we know time here, we know it's going to be the same time over there. So the first step we're going to do is we're going to use the vertical stuff to find time, go back, you put it here to find horizontal, and convert that to miles per hour. So to find time on the vertical side, one more time, the drop equation, y is VOT plus 1/2 AT squared. Because this is 0, that goes to 0. Y is 1/2 AT squared. Solved for time, 2y over a square root. And time is going to be square root of 2 times the vertical displacement, which is 40 meters. Acceleration of gravity, 9.8 meters per second squared. How long is the motorcycle stunt person in the air? 2 times 40 divided 9.8 square root. I got a glitch, 2.86 seconds. Meters are going to cancel meters. Seconds are in the sub-basement, are going to come up and then take the square root, so we end up with seconds. Now we have seconds. We can plug that back in on the other side. So 2.86 seconds. We know on the horizontal side you only have one choice of equation, x divided by t. X is 90 meters. Time 2.86 seconds. So what's the horizontal velocity going to be? 90 divided by 2.86, and we're going to end up with 31.5 meters per second. But they want to know that in miles per hour, so let's do a little converting. 31.5 meters per second. Get rid of meters, go to miles. We know there's 1609 meters in a mile. Get rid of seconds, go to hours, 3,600 seconds in an hour. So 31.5 divided by 1609 times the 3,600, and I end up with a horizontal velocity of 70.5 miles per hour, rounding that off to 3 sig figs. So pretty quick, but not crazy fast. All right, let's do another projectile problem. Now we're going to do number 15. The last few of these are projectiles shot at angles. So a football is kicked at ground level with a speed of 18 meters per second at an angle of 35 degrees to the horizontal. How far does it travel horizontally before it hits the ground? So here we go. Here is my football pitch, and we're going to shoot a projectile or kick a projectile off at 18 meters per second, and it's going to be 35 degrees above the horizontal. It's going to go doop, 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 and it's going to land some distance over here. It's going to have a horizontal displacement x, and that's what we're looking for. Now, every single time you have a projectile shot at an angle, what you must do first is break this into vertical and horizontal components. So I'm going to do this first one really carefully. Here is my projectile, 18 meters per second. This is my 35-degree angle. The original vertical velocity, this is the opposite side, so this is going to be the hypotenuse times the sine of theta. This is the horizontal velocity, this is the adjacent side, so this is going to be the hypotenuse times the cosine of theta. So the original vertical velocity here is going to be 18 meters per second times the sine of 35 degrees, and this one is going to be 18 meters per second times the cosine of 35 degrees. I'm going to grab my calculator and do both of these. 35 sine times 18. This first one is 10.3 meters per second. The second one is 35 cosine times 18, and I got 14.7 meters per second. Okay, now that I have those, now it's just a straight projectile problem. I'm going to have my horizontal stuff and my vertical stuff. Horizontally, I know the horizontal velocity is this bit right there, so that is 14.7 meters per second. I want to know x, don't know that, and I do not know how long it's going to be in the air. Where am I going to find time? I'm going to find that on the vertical side. I do know that 10.3 is going to be my original vertical velocity, and I know that its final vertical velocity is going to be a negative 10.3 meters per second. Now we have up and down motion, so if you've got motion in two directions, you have to define one as positive and one as negative. I like to call up as positive and down as negative. So my original vertical velocity, I'm going to call a positive 10.3, and my final vertical velocity, I'm going to call it a negative 10.3. What's going to accelerate the object in the vertical plane or the vertical direction? That's going to be our dear old friend gravity. Gravity is going to pull it down, and because gravity is acting in the downward direction, it's going to be a negative 9.8 meters per second squared. Looking at those variables, what can I use for time? Well, I'm going to use the old friend VF equals VO plus AT, and I'm going to solve for time. So time is going to be final minus original divided by acceleration. Final velocity was negative 10.3 meters per second minus original 10.3 meters per second divided by a negative 9.8 meters per second squared. If you ever get a negative time in a problem, it's an indication that you've got something going on before the clock started. So that's sometimes can happen, but usually not. I end up with these two negative signs cancel. That negative time sign, I end up with a positive 2.1 seconds is total time in the air. Plug that in up here. Horizontal, you know, the only equation you can use is x over t. We're solving for x is going to be horizontal velocity times time, and that's going to be 14.7 meters per second times our 2.1 seconds. So times 14.7, and I end up with a horizontal displacement of 30.9 meters. And that will do for that one. Okay, what problem was that? That was problem number 15. I think that will do. I think we got two of them in one go.